Hello everyone, welcome back to our Spring Boot series. Today I'll be addressing how to build the generic DAO. One of the things that usually happens is when we are developing a lot of classes regarding CRUD, like creating, reading, updating, and deleting data from database, we start to see that we have a lot of duplicated code. If we start with JdBC, we see a lot of duplicated code. And that's why we start to try to find about frameworks that can remove some of this boilerplate code that it's always doing the same thing. It's too verbose, and the only thing that changes is probably the parameters and the queries. And that's one of the reasons in Spring Boot that you start to use JdbcTemplate, because in JdbcTemplate, when you want to do a query, you just do JdbcTemplate dot query, you put the query, you put the parameters, the mapper, and that's it. But after a while, you start to see the code and you start to see, this JdbcTemplate to do a select, it's almost equal between all the queries, at least for single entities. The only thing that changed are the column names and the name of the table, and sometimes the RowMapper. So maybe I can create a kind of a generic DAO where my classes can inherit and I can reuse this code. I only need to parameterize somehow the columns and the table name and the RowMapper when it's necessary. And even the RowMapper, I can go further, because if the name of the columns are the same as the entity, and if I use a BeanPropertyRowMapper, or in this case it's just a BeanPropertyMapper, I don't even have to create a RowMapper. So I can simplify my code. And by the way, Spring Boot already contains a framework that is doing this. When you work with Hibernate or the Spring Data JdBC, you can just create interfaces, and you don't have to implement interface, but you just inherit from specific interfaces, and behind the scenes Spring Boot will generate code for you to create this generic DAO. But today I will teach you how can you start to build. I will give you a full implementation of a simple one that you can extend if you want, but I will provide you an example of how to build one with the advantage that you can take and extend it yourself. Of course, I will talk about its limitations, what you can do and what you can't do, when to use it and not to use it, but at least you have something that you can check and start and say, okay, maybe this is good for me or it's not good for me. So let's see how to build one generic DAO. So first, what is JdbcTemplate? If it's the first time that you are seeing this video, usually I create these slides. I have a project going on GitHub that you can follow if you look into my channel on the posts. And I'm talking these days about JdbcTemplate, but I will switch. Sometimes I switch to Beans, but in the next videos probably I will switch to other kind of subjects in Spring Boot, like for instance scheduling or caching or REST APIs versioning and things like that, and security probably will be the next ones. And maybe with high priority Spring MVC to use Timeleaf and create web pages, login web pages, those things that usually you need on your projects. Sometimes you need pages, sometimes you need REST API, but every time you are using REST API, you need security. And I will create, let's say, 1 or 2 videos from each one of these subjects, and I will go from there, and I will expect some comments on your side if you want to address specific ones, and I will prioritize these ones. So let's move on our slides. So what is JdbcTemplate? As an introduction, is part of the Spring framework, simplifies JdBC operations, as I was talking about moments ago, eliminates boilerplate code for connection, statement, result set handling, and supports queries, update, batch operations, and transactions. By the way, batch operation transactions probably will be my next videos about JdbcTemplate. So why reusable DAO classes? Reduce code duplication, and if you develop usually DAO classes, you will see you have a lot of duplication. Even when you are using JdbcTemplate, you will see some duplicated code. Centralized data access logic, meaning that simple things like selects, updates, inserts, and deletes that are quite the same, you centralize in one place, and if you test it well and if it's well developed, it will be great because you know that works. Then it's only the things that are different for each one of the use cases or tables that we are using, those will be the ones that you want to test. These ones, they are already there. And probably 50% of your queries, maybe I'm stretching too much, will be about simple things like insert, updates, deletes, and things like that they are always the same, so you can use the generic one. it's an approach. Some people don't like it. They like to do everything for each one. They say that in the future they will be able to change without impact on the others. That's right. The centralization always creates this problem that small changes can have a big impact on your application. So take this careful. Encourage consistency and testability, as I was saying, and aligned with solid principles, special single responsibility principle, and don't repeat yourself. Key benefits, so maintainability, less code to maintain. Of course, you are generalizing things, you are concentrating in one place a lot of similar functionality. Flexibility, easier to change implementation details. Testability, of course, can mock DAO interface. It's easy to mock the queries. And reusability, DAO logic used across service. You can reuse this across different entities, across different DAOs. Again, it's a good thing, but there is always the trade-off. A simple fail here has a big impact on your application. Best practice, using JdbcTemplate in a general way. Use interfaces for DAO. It's even for beans. It's always because later you can replace with a mock or a fake class for testing. Use RowMapper or BeanPropertyRowMapper. Okay, these are the two ones. In our case, we'll be using BeanProperty, but we can also use this one. As you will see, it will be configurable in our GenericDao. Parameterize with generics. Since we are using a generic, the name is already saying maybe you want to use the Java generics. You want to create a class that doesn't know which class you are using, a specific class, a POJO, but so you'll pass a generic, and maybe you want to get the attributes inside of the class. Inject the JdbcTemplate via constructor. It's a good practice for any database technology, JdBC technology in any DAO, and handle exceptions properly. I talk about this in my previous videos in JdbcTemplate, so check them if you want to learn more about which exceptions are thrown by JdbcTemplate, what they mean, and how can you address them. Basic DAO interface. Let's start with our implementation. Let's start simple, and my video will be about this simplicity. If you want others, you can take example from these ones. But these ones you can generalize quite easily without, let's say, negative impact. So find by ID. If you have a class, usually a class contains an ID. I will not say that this will work for 100% of the case, but usually all the tables have an auto number, something similar, which is the ID. It doesn't have to be called ID, but you have a specific column that is ID, and it doesn't matter what is the data type for the generic DAO. You have a primary key which an ID. If you want a composite thing, you have to probably create a class here. So the idea is, again, is you have the find by ID, find all, which is just a select columns from name of the table, a save, which constitutes an insert, an update, the name is already saying what it does, and delete. And usually these are quite common. If you get used to use, for instance, Hibernate or other object relational mappings, they use this kind of interface somehow. You have a kind of a generic DAO, and you have the type, your entity, user, category, entity, customer, shopping cart. It will be our T. Okay, it will be the return by the find, the list of those things, and the things that you want to save, update. And you have the ID. The ID, it's the data type of your primary key. Can be an integer, can be a long, can be a string. In the database, it's a varchar, but on the Java side will be a string. Don't use primitive types here. Use integer or long with capitalized L. Okay, and let's see how can we implement this to work with, let's say, 99% of the cases. So another thing that we will need, we should extend our abstract DAO. It means that we have this interface, we will create a class that will implement this interface. It's our class, not our final class. It will be our generic DAO. That will be, let's call it JdbcGenericDao. That will be the implementation. We'll have a full implementation to perform in a general way these operations, but we also need this one. This is an approach. There are other approaches that I can talk in another video if you want, but these ones are quite elegant. The idea is that we will need the names of the columns. You can say, okay, you can extract from the class, but sometimes the class, the name of the fields are not the names of the columns. And maybe you say, but I can put annotations. Yeah, and I would say to you, you are building Hibernate. but we don't want to build Hibernate because it's already developed. We still want to use JdbcTemplate without those annotations, things like that. We just the simple things that we have and extend. If you need more than that, consider to use something like Hibernate or JPI. JPI, it's the standard, I know, but you have Hibernate as an implementation, Eclipse Link. I think you have Open JPI if you want to use those. They use annotations to map the name of the fields to the column names. Okay, but you can try if you want to, let's say, customize the example that I provided to you. Great, you are like me, you like to test things and change them, so you better understand them later. So, but again, we have this method, so we have get column names, we will need them. We need, of course, the values of these columns. We want to provide this. So given an object, what will be the values for the column names? Okay, maybe you can replace this with a structure, with a map or something, but I'm making this easy. Okay, on the implementation, you can customize and let's say improve the example that I'm giving you, because I just want to explain you how to do it, not the best way to do it. Okay, so and then we have the get update value. Sometimes the update values are different from the column values. If you have auto number values, for instance, when you perform an update, you want to change a set of attributes, but usually the parameter in the query, the last one will be the ID. But for instance, on the column names, if you have an auto number, you don't want to put there the ID because it will throw an exception, because you are trying to insert a column that you shouldn't, because the value will be generated. That's why we distinguish between column values and update values. The update values need the ID to perform the filter on the where, but the insert needs the column values and it doesn't need the ID if you have an auto number. If you don't have an auto number, here the update values will be the same as column values and the same, and the columns will be all of them here. Okay, let's see a class diagram. So we have this interface, which is our GenericDao. Then we have this one will be implemented. These ones will be, let's say, somehow abstract because they should be overridden by our implementation, the specific implementation, user, entity, category, customer, and so on. But these ones, update, save, delete, find by ID, and find all, will be implemented here, so we don't have to implement. Meaning that to have a simple CRUD, we just create a class, we override these methods, usually just one line, and you will see an implementation. I have provided one, okay, but these ones, they are already there. Now you need, of course, if you need other methods, you have to implement other methods. Let's see a possible implementation. So we have this class, abstract class, because the idea is not to instantiate this class, but inherit from it and implements the GenericDao. And you have here that we have a constructor to receive the JdBc template. It's here on the constructor and it's stored here on this class. And now we have these methods here, which is the get RowMapper, get table name, get ID column, get column names, get column values, and get update values. So we need this because the ID column will be useful for the where we have a find by ID or update by ID. The table name, I think the name it's already saying what is its purpose, and the RowMapper, it's okay. So you have these columns with these names and you have this entity. How do you map these values? So maybe the column it's called ID on the table, but on my side it's called identifier, something like that. Okay, let's see an example for the find all. We have the select with the star from get table name and the get RowMapper. This method will be implemented, for instance, in it's abstract here. It means that you'll use polymorphism, meaning imagine that it's a user, so you'll understand the columns here, how should be mapped to the user that is instantiated on this find all, for instance. Of course, we'll see more about this, but this get RowMapper understands how to map a column to an attribute in the user, for instance. This one should all of them be implemented in our class. So let's see now find by ID. It's the same concept, but you can see here why do we need the get ID column, because of the where. And this is the parameter. And then we just perform JdBc template, query for object, the SQL, the RowMapper that we need, and the ID. You can see we are always calling this method because this method, it's here and it will be overridden in our implementation. For instance, user DAO, customer DAO. We'll see in a moment an implementation. Again, you have the delete, the same concept. Delete from the table name is generic one. It depends how the return value that we are putting on this method. Let's say return users, for instance, where the ID of the column that constitutes the filter, meaning the primary key, and again the parameter. And here we perform the update SQL and the ID, the parameter. And these methods can work to any class because there is no specific class here, just the data type of the primary key column that you can see here. And when we save or update, we pass the entity. And again, to perform an insert, what we need, if you go to the insert, we need the table name, which is returned by the get table name, which is on this method that should be overridden. Then you have these parentheses, then the list of the columns here, and the columns are the columns that we get from get column names. We can put directly here this method, but okay, but I want to put here the joined columns with a comma, things like that. So it's implemented like this to be, let's say, for educative purpose, but you can simplify, of course, all these lines. But you have here the join columns, meaning that the columns that you want to override on this method, get column names, are the columns that should work on the insert. And again, be careful with the auto-generated columns. And you have the values, and then now you have the placeholders, and the placeholders are of course, the same as the columns, but you want these interrogation points. And then you perform the update again with the get column values that should be on the application when they call this save to say, okay, give me the get column values. So you provide the entity here as a parameter, and inside this method that you will be overridden in your users DAO, customer DAO, and so on, you will say what values should address these column names. It will make sense when you see the implementation. And again, it just execute this, and the same for the update. But in the update, that's the thing that I said. You have the get column names, but for the values, it's a different one. It's the update values. If you don't remember what I said about the difference between this one and this one, because the update doesn't needs at the end, at the last parameter will be used here on the where. So your update values, it's a good practice to put the when you return a list of values, you return the last one as the identification for the filter, because it will be quite easy. When you pass the parameters here in an array, it will follow the interrogation points that you put on your update. And remember, this update, it's true to all the columns. Okay, if you have special ones, you should provide maybe you can put some parameters on the get column names for different queries, but that can be tricky. Again, I created this as a generic for simple CRUD. You can extend it, you can take this as an example and improve it, but for now that's the scope. Okay, let's see a concrete DAO implementation. You can see that it's really simplified because we extend this abstract class, but we have to override all these methods. And one of these is the table name, it's just users. The ID column, which is the primary key, it's ID. Now the column names that will participate, for instance, in an insert. So we have this name and email. But for instance, if the ID was not an auto number, you want to put here the ID also. But since the ID will be a column that it's only used in the update, delete, not in the insert because it's auto-generated, you don't put on the column names here. And then, of course, you have the column values, meaning that the generic DAO here, you get column values, will provide you the instance of the entity. So you say, okay, for these values that I'm using, this is, I want the get name and get email. And this is a way for you to map the name of the columns with the values that you want to address. It's a kind of a map you can use. And the update values, you can see it's the same, but we are providing on as the last parameter, the ID, the primary key, because on the update, you can see that the latest interrogation point here, it's the ID, not the first column. Okay, and that's it. With only this implementation, this user DAO have automatically implemented for him the find by ID, the delete, the save, the update, and the find all. All of them. So if you have a different DAO now, let's say for entities, you just said provide here entities, here ID again, and even if I think you can even simplify this one, because if you create a method that let's not complicate, but I think you understand what I wanted to do here. But of course, I was forgetting the RowMapper. In this case, I'm using the BeanPropertyRowMapper for user class because these names, name and email, are the same ones used in this class as the fields. Because this BeanPropertyRowMapper is something from the Spring that can do reflection on the class, and it can extract the fields and the values of the fields. In our case, we only need the names, so it will take the values and associate with these fields. Okay, but if they are different, you cannot use the BeanPropertyRowMapper. You should use the simple RowMapper, and in that case, you will say that this specific field should have this specific value. It's on your side, but it's a common. If you already work with JdbcTemplate, you already know what is a RowMapper. So now you have your bean. It's not necessary to be like this. It can be a regular bean in Spring. In the example that I will provide in a moment, it will be a regular bean, but you can also create it like this. So you have this user DAO and you inject the JDBC template on the perimeter, or you can have a regular one like a component or service or repository, and you just provide you inject the JDBC template. You say that you extends from this one, like one similar to this one. But you have, of course, to need an annotation here, calling, for instance, repository. In this case, it's just an alternative way. It's using bin, and it works the same way, as you know. So, and then you inject it like this, and then you can use something like users DAO, save, new user, you pass this information, and that's it. Behind the scenes, this save will call the save that you don't see here, but it's on the generic one. The generic one, the save will receive the entity, extract the column names. Which column names? The one that we provide here on this method, because we are using this user DAO and is extending from them, and it will perform the insert as expected. Okay, and I will show you in a moment this working. The find by ID, it is as easy as this one. And if you work with the Hibernate, you start to see, this is very similar to Hibernate, or maybe it's the Spring Data JDBC. Yep, it's very similar. But the Spring one, it's more powerful than this one because they can handle a lot of different scenarios. In our case, we are just handling 5 scenarios here. But it's quite nice. It simplifies one step further your code. Okay. Advantages over manual JDBC, lots of boilerplate using the manual. The reusable DAO, it's clean and concise code, harder to test, easy to mock and test. Yeah, it's already done. You test once and it's that. Prone to leaks. You have a lot of duplicating code. It can fail. This one, after it's really tested, proper resource management. There are a lot of repetitions, of course, associated with lots of boilerplate, and it's reusable and abstracted. You can even later to improve it, add more methods, maybe create some sophistication. But at some point, I think you should stop and start wondering, maybe I should switch to an existing technology that is doing the same thing. But for instance, if you are using something like a legacy application and create some wrappers, maybe you can go to some of the class that already exist and put the generic and clean some code. Maybe it's a start, and later you can move all these things to Hibernate. Again, I'm not addressing that Hibernate is better, but for simple CRUD, maybe it is. But for batch operations and hundreds of thousands of rows, maybe JdbcTemplate, it's always better and have better performance. So again, it aligns with good practices like solid principles, something that I will be talking in a specific video. It's quite important for clean code. Don't repeat yourself. We are avoiding this repetition with our GenericDao. Separation of concerns, business and data access logic, of course, when you use repositories, and the inversion of controls. JdBC is injected, so we are using the inversion of control. It's always a great pattern to have in our pocket. So some enhancements that you can add if you want to think about it. Support for paging and filtering, better filtering, paging, batch operations. Okay, it can be tricky, but it's possible if you look into the inserts. Now you have more than one row. Maybe rather than have an entity, you have a list of entities, but it should be similar in some aspects. Caching, you can always use Spring Cache in some performance. Audit logging, for that I will say Spring aspect-oriented program can be a solution. It will not be soon, maybe it will take a few weeks, but I will address aspect-oriented programming in time. So when to use this pattern? When using relational database, of course. When you want a light solution, no full ORM. You don't need an Hibernate, just want to simplify your code. You don't want to, you don't expect to later improvements on your code in this area. When you value testability and structure, not ideal complex object graph persistence, like for instance JPA. If you want relations, these entities related with this one and this one, JdbcTemplate, it's not the best approach. In a previous video, I explained how to perform complex queries. In JdbcTemplate, you can see that there is a lot of code that you have to develop. Okay, maybe you can simplify here and there with generic things, but JdbcTemplate was not developed to handle relations between entities. You can, but it won't be on your manual working. So testing reusable DAOs, use JDBC test. I will address this in my testing series. Use mock bin JdbcTemplate again in my testing series. Test only the custom methods in concrete DAOs. That's what, because the other one's already tested, generic DAO. These ones, it's the way you can do tests on JDBC, and Spring Boot gives you a lot of tools and great tools to perform tests and develop tests around the bins. Mock bin on the JDBC template, it's quite easy to use, JDBC test, but I don't want to enter into much details here. It will be completely out of scope. But let's say that our solution, it's aligned with how Spring Boot does things. Conclusion: promotes maintainability code, encourage abstraction, which is always a good thing nowadays, simplifies JDBC, remove more boilerplate code, great for microservices and simple database layers, use it as a template for scalable data access. Maybe I'm exaggerating on this point, but okay, but maybe you can take it. So thank you for watching this. I will show you now a possible implementation of this generic DAO in our application. So what I did was develop a generic. Again, you can check out this code from the GitHub that is in the post area of my channel. So let's see, I have here our generic DAO. It's the similar one that we saw in our in the slides in the presentation. So I have generic DAO. The T represents the entity. The ID is just a generic for the data type associated with the primary key that will be used, for instance, in find by ID, delete by ID, for instance, here. And we have the delete by ID, update, find by ID, and find all, the ones that I explained earlier. Now you have this an implementation. I did some adjustments, but it's quite similar to the one that I explained. So we have here the constructor to make sure that we have a JDBC template. It should be injected by our class. Of course, we need all this protected. So we want to make sure that our class will implement in a mandatory way these methods: the RowMapper, the table name, the ID column, as I explained during the presentation, the column names, and the update values. Remember that the column names should be the names of the columns without a column that is auto-generated if you have one. If you don't, put all the columns here. And the update values, it's similar to the column values, but occasionally you want to put at the end of the values the ID of the primary key. And okay, I said column names as, of course, column values. And now it's the implementation, as I explained earlier. So in the select, we have the get ID column, then the column names. Since we are not using in the column names, and in my example, I'm using auto-generated, I'm prefixing here the ID column because I want to select to return also the ID column. And again, just the from, find by ID, it's again, I want to return the ID column and the column names. And of course, I want the where, use the get ID column. In my case, it will always be ID. Now the save, it's the same. So insert into get table name. Here you can see that I have the get column names, but not the ID column because I have an auto number. Okay, it's by the way, I can show you. I will be using this one, the simple one. It is this one, the entities. And you can apply to these ones. It's the same concept, but you can see that the row, it's auto increment, so it doesn't it's not included in the insert statement, for instance. That's why, but I want it to be available in selects. That's why I'm using here the ID column on the selects, but not on the insert. Okay. Now you have the save, the same for the delete again. The ID column on the where, the name of the table here, and the update, it's all the columns, column names. Of course, the ID, it's not here, that's why it's not, because again, it's an auto number. And here I get the ID column. If it was not an auto number, your get column name should return the ID. And that's okay, probably. Your ID will be on the values you put also the ID. You don't want to change the ID in an update, but it doesn't hurt to update to the same value. It's an idempotent operation, so that's no problem. And then you get the updated values here, and you perform the update. This is implementation. If you study this code, it should be that it's quite simple to understand, and it works for any entity, okay, with auto numbers or not. Of course, the trick will be here on the, where is my, entity repository. You can see now my entity repository, which is a repository, extends from the Jdbc GenericDao, which means that insert, update, delete, it's already included, the code that I was showing you in a moment. Now my RowMapper, I want to teach how to map the values that came from the entity. And I say, okay, my mapper, the names that you need, it's the BeanProperty, meaning that the name of the field of the entity, this name ID, and this name are also the name of the columns. Okay, that's otherwise you have to create a map, as you know, in the RowMapper, and explicit this ID, maybe it's identification, and the name is probably entity name. It can be the case. In that case, you have to create a RowMapper. Otherwise, if they are the same name, you can just use the BeanPropertyRowMapper provided by Spring that will do reflection on the entity and will extract and create a RowMapper for you. Table name, just the name of the table. ID column, it's the ID, the primary key. And the get column name, since I'm using auto-generated number for the ID, I only provide here the name. I will not put the ID here. Otherwise, do we insert? We'll try to put the ID and you have an error saying you are trying to insert a value on a column that shouldn't receive an insert. Okay, that's what happened. And of course, the values, usually you have a relation between column names and column values. So if you have here the name, you should provide here on the same order how to get this name. If you have a second column, of course, you put here the second column. And now on the update values, I have the name. It's similar to the column names, but I want to provide the number generated, which will be the filter for the update here as the last parameter. And that's it. And I've created here, of course, on the REST controller. For entities, we already had this one on a previous version. If you are following my videos, here I just created a post, a put, and a delete. Quite simple, I receive an entity, and I will call the create entity on the service, and the create entity just calls the save. And you can see this save, it's the generic one. Okay, which is here. But since our class, our implemented class, that it's here on the service, if you see the class injected its repository, but since it extends on GenericDao, you have access to that save. And you have here for the save, for the find by ID, and for the delete. Okay, you have all of them here. Find by ID, update entity that updates and get all the values to be returned. So these three operations I created new, but they follow the same pattern that we did for the other category. So let's play this. Everything it's the same. If you saw my previous videos, you understand. If you want to look at the code again, it's available on the posts area. The address of the GitHub, it's on the posts area of my channel. And now I have here a set of REST. I'll just put this, I will clean this here so you can see the results. So get all entities, so you can see how many entities we have, and you can see this working. So this is calling the find all. Remember that again, the find all, it's not anymore in our entities repository. It's on the generic. So it's calling the generic method to get all the entities, and it's working. You can see here the results. Okay, now get by ID, for instance, you can see by one. Here I'll create a new one using the GenericDao. This is because I'm not getting, if you go into the entities repository, and it's an enhancement that you can add when you have auto-generated. I think I put it here when I create one on the insert, where it is, our GenericDao here, JdbcGenericDao. On the save, you can see here on the save, I put here in a real scenario, you might want to return the saved entity, meaning that maybe you want to put some parameter here or a way to know if this entity is using auto number or not. And if it's using auto number, you can put some logic here to return or set the ID, and you know what is the column that is ID, with a value. And in my previous videos and in other places, if you go to the users, here on the users repository, I'm sure I have an example to show you how can you get a generated value. I think it's somewhere here. Yeah, you can see here. You can take this code if you want to take it on the users repository to teach you how can you get generated values. Okay, let's return to our This is insert. Now let's do a put on the 1. So this is an updated entity on 1. Let's prove that this is working. So if I get all of them, you can see now the first entity was updated. And now let's delete the latest one. I don't delete the 1, 2, or 3 because they will have foreign key errors, but the fourth one, it was removed. You can see, and we can comprove here. We have the 3 and you have the 5. So the fourth one, the one that we deleted, was removed. So you can see that GenericDao is working, and maybe I hope that it can simplify some work from you. So I hope this video was useful for you. I hope you like it. Please subscribe my video, share with your friends. It gives me motivation to keep going on these videos. I really like to share my knowledge. I learn from it. I consolidate my knowledge when I'm trying, because I try to be as perfect as possible on my slides and explain everything that happens. So it teaches me also sometimes some details that I was not seeing at first. So I think it's a win-win for all of us. So again, thank you for watching, and I hope to see you in my next video.